Hello, everyone. A very warm morning, afternoon, and evening to every one of us joining across the world. I, Dr. Neha Tiwari, welcome you as a host of ICICT 2020. Dear authors and invited guests, welcome to Technical Session 5E. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are well aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances post-COVID and making this conference more productive. Also, we wish everyone and their families a protected time. We hope you all will enjoy 2 days of knowledgeable and interactive digital sessions. There is a special note for the presenters. You all will be given 10 to 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we get started, I would like to introduce you all to the chair for this session, Professor Roshan G. Raghel. Dr. Raghel is a full-time professor in computer engineering at the University of Pennsylvania. He is a skilled university lecturer and researcher with a doctorate in computer science and engineering from Australia, and he has a passion for teaching, research, and administration. His research interest is in the areas of fault tolerance and dependable computing, accelerated and high-performance computing, variable computing, and synthesis of secure and reliable embedded processors. I welcome you, sir. If you permit, we may now start with the session presentations.
Yes, please.
Sure. With your consent, I invite the very first paper presenter of the day, O.L. Makalusi. I hope I pronounce your name correctly. He's from South Africa and will share his views on factors influencing the selection of a blockchain platform for incorporating data provenance into smart contracts. I request you to start with your presentation and kindly keep the time limit in mind. Thank you.
Hello, everyone. Can you hear me?
Yeah, we can hear you.
Can you see my screen?
Not yet.
Can you see my screen?
Yeah, I think it has started. We can see it now. You can start with your presentation. Thank you.
Okay, my topic is about factors influencing the selection of a blockchain platform for incorporating data provenance into smart contracts. My overview will look at the background, the factors influencing the selection of a blockchain platform, then various blockchain platforms. Then finally, we'll compare and analyze blockchain platforms with respect to their factors influencing the selection of a blockchain platform. And then we'll end with the conclusion and the future work. A prominent application of blockchain smart contract is in manufacturing supply chain. I made reference to one of my papers exploring the means and the benefits of including blockchain smart contracts to a smart manufacturing environment using a case study of a water bottling plant where I collect data. This data is pertaining the pH and the manufacturer information. That data is then incorporated into a smart contract. Then the end user then will then scan the water bottle to retrieve the data provenance from the manufacturer through the blockchain. So what is provenance? Provenance is defined as a place of origin or the
هلا ابو عبد الله.
of a
موجودين
product
بس اثنين بالغرفه.
which is tamper-proof
بس
and
اثنين
its
يسوون
integrity across the supply chain can be verified. A prominent application of blockchain smart contract is in the modern, sorry about that, I got distracted a little bit. Blockchain is the write-only distributed database, which its transactions are trackable, irreversible, and can only be added, not edited or removed. However, there are certain factors which need to be considered while selecting the appropriate blockchain platform. This includes consensus mechanism, performance, maturity, centralized or decentralized operation, cost, just to name a few. This research aims to compare factors influencing the selection of blockchain platform against some of the common blockchain platforms available for incorporating data provenance in the modern manufacturing scene. Traditional supply chains have always been looking at ways in which operational process can be optimized to yield greater profits in minimal time. However, consensus mechanism properties such as security, energy consumption, finality, throughput, and scalability are some of the contributing factors in selection of a blockchain platform. Consensus mechanism is an algorithm used to process, verify, and approve blocks with transactions by computational resourceful miners in the blockchain platform. Blockchain miners have to find what is called a nonce, which is a number that blockchain miners have to solve for to link a block onto the blockchain network for a gas price reward. There are several existing consensus mechanisms, which includes not limited to the proof of work and the proof of stake mining algorithm. So if you look at proof of work, it's basically a fee model based on an auction mechanism, which is a first price auction. The auction mechanism is when miners are profiting from picking up transactions with the highest gas price. Users can also choose between slow, average, and fast confirmation time, or specify a gas price manually, having an influence on the performance, which includes throughput and transaction latency. Escalation of high gas prices of the network resources has influence in the selection of a blockchain platform. The development and implementation of consensus mechanism algorithms, which limits number of miners on the network, was paramount to automating the fee bidding through a few validators with the use of what we call the proof of stake. So meaning fewer number of miners on the network means lesser consumption of electricity. This will also make cryptocurrency mining sustainable, less profitable for miners, and reduce gas fee estimation for incorporating data provenance into smart contracts. If you look at the taxonomy of the blockchain-enabled smart contract-based studies, it's mainly for improvement proposals covering technical specification of resource-driven and optimization of smart contract. Other studies have been proposed for smart contract optimization by reduced transaction cost. Blockchain platforms have factors influencing their performance, which include scalability and throughput and transaction latency. Throughput is a quantity of data being sent and received within a unit of time, such as transaction per second. Users can choose, like I said earlier, between slow, average, and fast confirmation time, or specify a gas price manually, and thus having an influence on the throughput. If we look at mature platforms, typically they have the capabilities of interoperability, vendor support, and stronger development community experience. interoperability, which offers scalability, resulting in high throughput in terms of transaction per second. Blockchain platforms like Ethereum have stronger development community experience, which offers several tools for implementing, testing, and developing of smart contracts and decentralized applications. The cost is one of the measures implemented to avoid issues of network abuse. Computation resources execution in Ethereum are subject to the unit of gas fee. Computation resources within the network is rewarded with a transmitting value, which is a gas price measured in GWA. For example, if you look at the Ether, it's 1 to the power 18. So I looked at 4 platforms, which is Ethereum, Polygon, and Ethereum 2 and Tron. Ethereum 1, I'm going to call it Ethereum Legacy. Ethereum Legacy, which it's a smart contract blockchain platform, development platform of choice, which forms layer 1 in terms of the blockchain architectural layers, based on its security, interoperability, and developer experience. Ethereum Legacy currently adopts proof of work as a consensus, which offers a low throughput, high transaction fees, and no sovereignty. Whereas Polygon is a layer 2 solution for Ethereum, Polygon enables interoperability, which combines the best features of a standalone blockchain, with sovereignty, scalability, and flexibility. Polygon currently adopts proof of stake as the consensus algorithm. If you look at Ethereum Legacy has matured now to Ethereum 2.0, which is implementing of improved proposal, which gets rid of the first price auction that I spoke about previously. It's in phases. It will, on its completion, it will enable the prediction of transaction fees and reduce throughput bottlenecks. If you look at Tron,
I would ask you to sum up your presentation in 2 minutes.
Okay.
Thank you.
Okay. I'll jump Tron quickly. If we compare and analyze with the infinite blockchain platforms, the comparison of the following blockchain platforms, Ethereum 2 and Ethereum 1, Polygon and Tron. With respect to Tron, the cost of Tron and Polygon platforms are lower than Ethereum Legacy. Ethereum 2 is still in its early phases, so mainly in the test network. So test network transactions are not really considered since the gas is free on the test network. However, Ethereum on full implementation will offer no first price auction, which means it will result in lower cost. With respect to performance, Tron blockchain platform is higher than Ethereum. With respect to throughput, Ethereum 2, Polygon and Tron blockchain platforms are higher than Ethereum Legacy. With respect to consensus, Tron blockchain platform offers the preferred delegated proof of stake, which is better than Ethereum Legacy proof of work, which is efficient regarding the auction mechanism. With respect to the cheapest transfer fee, Ethereum 2, Polygon, Tron blockchains are lower. However, Tron remains outstanding as it offers higher performance, followed by Polygon. So future work, quickly, consensus mechanisms such as proof of work mining algorithm has a major contributing factor on security selection of blockchain platforms. Future work, blockchain platform, however, future work experiments are proposed and will be conducted on the main network. A blockchain platform which is the most cost-effective and higher performance will be confirmed using a smart contract with data from the water bottling plant, which will be incorporated into a smart smart contract and deploy it into the main network. Thank you very much.
Thank you, Lucky. I now request the session chair, Dr. Raghil, to start with his questions regarding the presentation, if any. Thank you.
Yeah, thank you. Thank you for that nice presentation. I have just one question. The study you have done, is it only based on a literature survey, or have you also done some performance testing?
At this stage, is done on the reviews, literature study. Hence, on the future work, I'm proposing now to take the actual data and now incorporate them into a smart contract and then deploy them to the main network, and now compare what I've just the literature review and the actual data I would have deployed to the main network.
Thank you.
Thank you very much.
Any questions? Thank you. We
Thank
now
you.
move on to the next presentation, which is from Romania. The presenter is Sorin Ionut Salco. His paper title is Integrating the Behavior at Reactive Power Flow in the Model of the Single-Phase PWM Rectifier. I apologize if in case I've pronounced your name wrongly.
It's okay. It's okay.
Please start with your presentation.
Okay, just a second.
I request you to also keep the time limit of 10 minutes in mind. Thank you.
Okay. Do you see my screen?
Yeah, the screen is visible.
Okay.
Please start. Yeah.
So my name is Sorin Ionuț Salcu. I'm a PhD student at the Technical University of Cluj-Napoca in Romania. And today I will try to give a brief presentation of the paper intitulated Integrating the Behavior at Reactive Power Flow in the Model
Can we
of the
have the
Single
full
Phase.
screen view, please?
The full screen view?
Yeah.
So
Kindly run the slideshow. Can we have the slideshow, please?
So you don't see the slideshow?
No.
How about now? Is it okay?
Yeah, thank you.
Yes, it's okay. Okay, sorry. I have two displays and I probably missed it. So the paper concerns in proposing a new way to model the operation of the single phase full bridge PMW rectifier circuit in a manner in which both the positive and negative, so the active and reactive power flow is integrated. So this model aims to offer a general perspective on of the converter operation, and it can be used if one wishes to perform some control techniques and to optimize the behavior of the controller. As we know, this kind of topology of AC to DC converter can be controlled to shape the input of the current in order to match the grid voltage. Also, having a full bridge, can assure bidirectional power flow, and so it can be used to power line conditioning and mitigate the effects of reactive power in the grid. And we can say it can have a friendly behavior to the AC power grid. So the paper starts with the model of the converter for the positive power flow. So as it's usually used and presented, for the positive half cycle of the input voltage, the switching states of the converter can be divided in this to present it here. I also have to mention or remind that the converter usually works with a boost effect. So the output DC voltage has to be higher than the peak voltage of the input. In this first switching state, the inductor L is charging, and the capacitor C is assuring the power to the load. In the second state, the input voltage and the energy from the inductor are both supplying energy to the load. The equation describing the circuits and the steady state matrices are presented below. So I have to remind that this representation concerns the positive power flow, positive meaning that the direction is from the AC source to the load. At negative power flow or reactive power, the converter behaves similarly, only in this case, the input voltage sign is negative. So the input current keeps its direction of flow, but the input voltage is reversed. The switching states are presented here. So switching state 2 with a star is similar to switching state 2 when the converter flows, or the input current flows and supplies energy to the load. But in switching state 3, the output voltage being greater than the reverse input voltage determines that the output capacitor provides energy both for the load and for the charging of inductor L. The state space averaging of the converter's operation for both positive power flow and negative power flow, so switching states 1 and 2, and 2 star and 3 are presented below. The question that rises is, what if the converter operates at an input phase that's in between? So it's not at negative power flow, like in regenerative mode, or it's not at positive power flow, so the power flows from the grid to the load, but somewhere in between. More precisely saying, the phase shift angle between the input voltage and the input current, it's not pi over 2 or 90 degrees, or it's not 0. So both positive and negative power flow should be contained in this model, because they are both manifesting at the same time. And the question is, can we take into consideration the average power values of the variation of the average power value to help characterize this behavior? And this is what this paper proposes. So concerning the way that an AC power or its average varies with the varying phase shift between the input current and the input voltage, yes, we can see that the average input power, so the average of the area, tends to go to 0 as the phase shift tends to become closer to pi over 2 radians. In this graph, a representation of this variation can be seen. So from 100% yes active power, the average power decreases to 0 as the phase shift of the input sign voltage and current reaches pi over 2. In this manner, the paper proposes an approach in which two averaging or weighing coefficients describe the amount of active and reactive power at each point of phase shift in time. So in this equation, V is the phase shift angle measured in radians. It can be seen that the function that describes this variation is actually a cosine function, or cosine function, and the coefficients are presented here below. Having this in mind, the general representation of the state average, so the one that includes both the states at active power flow and reactive power flow, can be quantized by these two parameters. So obtaining the linearized small signal model, as shown here, where the E element is this sum of matrix as presented below. I've colored the coefficients, so Q1 and Q2, in order to show their presence in the final representation, and to mention that they once again quantize the amounts or the impact that each of the states have on the final result. I will go directly to the results. So the obtained transfer functions from the small signal average model presented here are the duty cycle to state variables. So the duty cycle being represented by capital D, to the state variables that are, of course, the input inductor current and the output capacitor voltage are presented here. And once again, the presence of those two quantification elements can be seen in the transfer functions. Nevertheless, the input voltage to state variables of the input voltage to the input currents, the inductor current, sorry, and the input voltage to the capacitor voltage transfer functions are presented here. If we look closely, the parameters are presented, so they find themselves in these representations as well. As conclusions, the general model of the single phase PMW rectifier has been proposed. The integration of both the positive and negative power flow for an intermediate state has been studied, and a correlation between the average variation of the input power and this implementation has been proposed. The resulted transfer functions, as it can be seen, are dependent on the phase shift, and so the input and voltage and current are being responsible, yes, for this manifestation, and the resulted expressions can offer a flexible mean in observing the converter behavior. Thank you very much. I've tried to be.
Thank you so much, Soren. Can I have some queries from the attendees? I would request Professor Ragil.
Yeah, I'll start with one, and then Soren, thank you for the presentation. And I'm not a power expert, so just to understand some applications. So applications and implications. So in terms of your finding, how can you give some idea on the application of or the implication of the finding in some common situations? Yeah.
Okay. So the application of the finding can be discussed in terms of creating a proper control law for the converter, because it usually works in one state. So either is at positive power flow, so you supply energy to a load, or it's in regenerative or negative power flow. But it can be put in an intermediate state in order to, I don't know, mitigate maybe reactive power, or to participate in some power quality enhancement in the distribution grid. So it's just a way in order to assure that the design can be optimized.
Yeah, understood. Thank you very much. Yeah, that's good.
Thank you as well.
Thank you so much, sir. Thank you, Soren. We now have A. Sarishwale from Germany with us. He's going to present his views on paper titled Sparse Inversion of Stacked Autoencoder Classification Machines. I request you to start your presentation.
Okay, thank you very much. Can you hear me?
Yeah, we can.
Nice. Perfect. Okay, I share my slides. Okay. Let's talk about inversion of stacked autoencoder classification machines. This work is done by, founded by Fraunhofer Cluster of Excellence, Cognitive Internet Technologies from Germany, in cooperation with my institute where I'm working. My name is Alex Arashvili, and my institute is Fraunhofer Institute for Industrial Mathematics in Kaiserslautern. And my colleague Matt Dürstand is from Fraunhofer Chalmers Research Center for Industrial Mathematics, Göteborg in Sweden. Okay, let's motivate the situation, and in the second part, I show some brief overview of mathematical background of this approach and evaluation. Yeah? On the right-hand side, we see some fraction of MNIST data set. This is only for this is have been used in this paper, but it's not necessary to use this image data. Yeah? This works also on non-image data. And what we see here is this digits. Yeah, there are 28 times 28 pixel digits, and the main task in the machine learning community is how to classify them. Yeah? You have this intensity data from pixel intensity data from each image, and you want to classify these two digits. So, and so this is of course an important task, because you can generate if you can now invert this situation, then you can generate a new images which are similar to the digits. Yeah, and these new images you can then use for enhancement of data sets, for example. Yeah, this is the point. And now to the approach itself. Yeah, we want to invert this forward classification. On the right-hand side, you see here, what you see here is the approach. Yeah? So input, this input is our vector of pixel intensities of these images. You have 728 times 28. This is 784 dimensional vector of pixel intensities. And this is autoencoder. What is doing autoencoder? Autoencoder is generate this latent representation here, and it have encoder and decoder. And this latent representation now is fed into the second autoencoder, which is then generates the second latent representation, which is then fed into the sparse coding step. I explain it in the next slide, what is doing here. And after sparse coding step, we can go on and classify them by softmax layer to the output, and the output is class. Yeah, for example, the pixels which is going into the input is to belongs to the class 8, and 8 is this digit. Yeah, so what is the backward? Backward is inversion. This means it starts by generating query, and this query is vector of a probabilistic vector. That means you can generate your arbitrary query. For example, you want to generate a digit which is a mix from 2 and 3. Yeah? So this can be query. You can code it. This your idea, you can code it in this probabilistic vector. You say, for example, 50% of mass should be on 3, and 30% of mass should be on 2, and the rest of the mass of the probabilistic mass should be on the rest. This is the point. This query is going into the compressed sensing step. This compressed sensing step is solves the underdetermined system of linear equations. I show you it on the next slide. And by using this sparse coding step, and generates this latent representation. This latent representation, this so-called reconstruction, is now fed into the decoder. This decoder generates the first latent representation. It is fed into the first autoencoder decoder, and we got this reconstruction. Yeah, this is all. How it is done. First step is this sparse coding step. Sparse coding, standard sparse coding is solving this optimization problem, which is the two parts, consists of two parts. This is the loss function, standard loss function, And you have here this L1 n-bar regularization term. This is you are looking. This is XE is our latent representation. The second last latent representation of our stacked autoencoder. You see. You are assuming that the XE is embedded into the dictionary D and alpha E, and alpha E should be very sparse. Yeah, you have here L1 norm. That means you are searching for alphas which have small number of non-zero elements. Yeah, therefore L1. This is like lasso. Yeah, as a lasso idea. So. And this is done by this two-step optimization. Yeah? In the first step, we are optimizing alpha, which is k times n vector. K is the dimension of your dictionary. D, yeah, it should be very large. We are talking here about we are talking here about redundant dictionaries. Yeah. And n is the number of your data. In the MNIST data set, you have 60,000. Yeah, this is here, and you are minimizing this by using some initial matrix of the D0 of dictionary. In the second step, you take this alpha, putting here inside, and you are minimizing over D. And this is now iterated here many times to reach some standard performance measure, and then you stop. And you after that you will get D dictionary on only one matrix and alphas. And alphas is the matrix of k times n vector matrix. Yeah, that and each column in this matrix is sparse representation of your data, which you have already. For example, in MNIST data set, you will get 60,000 times. Although you need not 60,000 k is here 400 or so in our implementation. Also 400 times 60,000 metrics of alphas. Yeah, and the alphas are very sparse. They have only 5 elements. Yeah, in these 400 dimensional vectors, you have only 5 elements, 5 non-zero elements inside. Yeah. Now go on and we generate the query. Yeah, query is, as I said already, this is our masses on probability masses on your some classes. For example, class 2 should have 70%, and class 090 should have 0.3% of mass. So 090 itself is coming from the active learning step, which is described in the paper. I don't have here the time to describe this, but we enlarged the number of classes from 10 original MNIST data set to 36. Yeah, and 66 new classes have been coming inside by using these active learning steps. What is doing compressed sensing? Compressed sensing solves the linear underdetermined system. Yeah? You have this system, and you want to, this Y is our query, and this X is our latent representation here. The second latent representation is our X. Now we want to get X out from this. Yeah? And this is the linear underdetermined system, and this is ill-posed, and it's not. There is no unique solution for that. Yeah. So, and what is this doing? If you have some sparsity condition on X, the situation is changed dramatically. Yeah. That then you can find the exact solution for X. This is the theory which is described in paper in more details. Yeah. So the situation is the following: we have the query Y, we have some random matrix, we have the dictionary D, which is coming from sparse coding step, and we have this sparse vector, which have only 4, 5, or 6 non-zero elements. This K is the number of so-called atoms in this dictionary, in this redundant system. And in our implementation, K was 400, and sparsity coefficient here was 7. That means we had only 7 non-zero elements in this sparse alphas. Yeah. Now we have alphas tilde. what we can do with alpha tilde, yeah, we can go on and adjust alpha tilde using the data which we already have. For example, for MNIST dataset, this W is now the weight vector of the softmax layer here. And these,
Alex,
the dictionary, yeah.
kindly concluded it last 2 minutes. Thank you.
Yeah, okay. Okay, thank you. I will do that. This is the adjustment step. Okay, I can only say that here the assumption is that the alpha hat, which for which we are looking for, have the same sparsity and on the same positions as alpha q tilde. Yeah? This is the point. So what we have done is you see here the example, which is coming from MNIST dataset. We here O are original picture image and R are reconstruction. Yeah, we have here 10 times reconstructed the 0, 10 times 1, 2, and so on. And here these numbers are the classes. Yeah, for example here what we can take here 17. Yeah. 17 is the mix of 1 and 7 digits, which are here represented by this data. Yeah? For example, 3 and 9 here, yeah, and so on. And the R's are the reconstruction. Yeah? So practical usage or use case of this approach is coming from the extrusion, yeah, from the extrusion process. You have here your engine, you have gearbox, screw, this plastic granulate and recipe of this granulate, and what you are getting out is this, for example, insulating plates, yeah, for houses, from outside of houses, yeah, and this is your process parameters, yeah, and query is now which quality this your insulating plate should have. Yeah, so this is your query that you say, I want these quality parameters of my insulated plates. Yeah, how I can adjust my process parameters, or how I can set the process parameter to get this quality. Yeah, this is the inversion step. The forward step is clear, from process parameters to the quality parameters, and backward step is now for from quality parameters to the process parameters. And we have also done this. The results are very good because we were able here to use this Ludovic simulation tool to simulate everything, and here three-dimensional quality parameters, temperature, product energy, and pressure have been generated. These queries feed back, inverted. We got these process parameters, and these process parameters we got back into the simulator, yeah, and we got the results, good results for our approach. Here in this MNIST dataset, we used the so-called PNSR, pixel noise to signal ratio, to measure how good this is, and it was better than or similar result like the C-GANs, for example, yeah? And much more simpler. Thank you very much. Any questions here?
Thanks a lot, Alex. I'm not sure if we have some queries from the attendees. So I would directly go to Professor Raghil for his comments on the presentation. Thank you.
Alex, thank you for the presentation. Just one quick question. How do you compare your encoder with the previous work, like what's already available?
Yeah, this is a good question because this is not so easy to compare, to make some comparisons. For example, here you can go on and see and calculate this PSNR value. Yeah, this PSNR value compares reconstruction with the original value. In C-GAN, for example, you don't have any original value to compare this. Yeah, therefore we compare this with the other approaches which are also which are also inverting this type of images. Yeah, and in paper you can see which approaches we've used there. Yeah? But the performance measure was this PSNR, so the standard measure for images and so.
Thank you, Alex. Interesting work. Thank you.
No, thank you too.
Up next, we have Sushiu Vasil Mihai from Romania. His paper title is Analysis of an Independent Double Boost Interleaved Converter Operating as Power Optimizer in a PV application. I request Sushiu to start with his presentation. Thank you. I hope you can hear me. Yeah. Okay, so I started with the presentation. Please bring it to the full screen view. That's better. All right, we can start. We can't hear you, Sushiu.
Okay, sorry. I
That's
think now
absolutely
you
okay.
can hear me.
Yeah, absolutely.
Okay, thank you. Good afternoon. My name is Vasile Mihai Suciu, and I'm a PhD student at the Technical University of Cluj-Napoca from Romania. I'm here to present our paper intitulated Analysis of an Independent Double Boost Interleaved Converter Working as Power Optimizer in a Photovoltaic Application. The aim of this study is to analyze the behavior of a DC-DC converter named Independent Double Boost Interleaved Converter with 3-level output, working as power optimizer in a photovoltaic application. The power stage of the proposed converter topology has been used as an interfacing element between the deserved load and 3 photovoltaic panels. Several tests of the DC-DC converter were performed using MATLAB Simulink and Plex block set co-simulation model. The working principle of the specified power stage topology was studied in the context of a renewable energy application, which involved 3 copies of the same DC-DC converter with their outputs connected in series. Here it can be seen the electronic diagram related to the simulation model developed in MATLAB Simulink in conjunction with the Plex block set. By using the Plex block set within MATLAB Simulink, a co-simulation approach of the control loss and the DC-DC converter's power stages has been done. This configuration has been used as an interface between 3 photovoltaic panels and the deserved load. So in this configuration, every single DC-DC converter has been used to harvest the energy from every single photovoltaic panel. The control loss of each DC-DC converter, which has been represented by the perturb and observe maximum power point tracking algorithm used to extract the maximum power from each photovoltaic panel, together with the photovoltaic panels, has been implemented using MATLAB Simulink native toolset. The power stages of the analyzed DC-DC converter have been implemented using the Plex block set add-on. The deserved load consists of a variable resistor, and the equivalent resistance of the load has been modified in such a way that the output voltage was maintained constant around 500 volts, regardless the overall output power or solar irradiation level of each independent solar panel. In this way, the load behavior can be emulated as a grid inverter, usually used in conjunction with power optimizers. Here we have the block diagram of the simulation model developed in MATLAB Simulink in conjunction with Plex block set. The model consists of 3 PV array blocks used for emulating the characteristics of 3 Canadian solar panels. The perturb and observe MPPT algorithms subsystems, and also we have here a subsystem in which we have the DC-DC converter power stages implemented in Plex block set. Here it can be seen the perturb and observe control law diagram implemented in MATLAB Simulink environment. Multiple simulation of the power stages operation were performed and recorded for the cases in which the profile of solar irradiation across the photovoltaic panels had different values. The temperature of the photovoltaic panels has been set at the value of 25 degrees. It can be observed here that in the time interval 0.5 seconds, over the first 2 PV panels, the same solar irradiation level has been used. And over the third panel, we have a different values of solar irradiation. But in the time interval 0.51 second, over all photovoltaic panels, we have the same values of solar irradiation, 1000 watt per square meter, respectively 500 watts per square meter. In the left figure, we have the photovoltaic panels power. So we have the PV power. Also, we have here the voltage at the terminals of each photovoltaic panel and the currents of each photovoltaic panels. Here we have the duty cycle used for each PV module, and these are presented in correlation with the values of solar irradiation across the PV modules. In the right figure, we have the inductor currents for each DC-DC power stage that are shown for different values of solar irradiation in relation with the duty cycle of each DC-DC converter. It can be seen that in the time interval 0.56 seconds, the power and the current of the first 2 PV panels are the same, and in the time interval 0.51 second, where all the panels are irradiated with the same values of solar irradiation, the PV module power, currents, and the DC-DC converter inductor currents are the same for all photovoltaic modules. In this figure, the voltage waveforms across each DC-DC converter output capacitor are shown. Also, the output voltage and current waveforms are presented related to the solar irradiation levels applied to the PV panels. The efficiency of each DC-DC converter power stage was determined with strict consideration of the power losses they may occur in the electronic switching elements, for example, conduction or switching power losses, and with the consideration of the conduction or ohmic losses that may occur on the passive components. To determine the power losses that may occur within the electronic switching device, a thermal design using elements from thermal library found in Plex environment has been performed. Switching and conduction power losses of the transistors used in the power stages have been determined using power loss curves provided from GAN systems for this type of transistors. For the diodes, only the conduction losses, power losses were considered, and we have here the curves for this type of diodes provided by V-shape.
A gentle reminder to you to sum it up within 2 minutes. Thank you.
Okay. Here we have some efficiency simulation results. In table 3 are shown the calculated efficiency of each DC-DC power stage for different time intervals. We can observe that the maximum efficiency is achieved here in the third interval when all 3 PV modules are irradiated with the same values of solar irradiation that equal with 1000 watts per square meter. As a conclusion, in this paper, a brief analysis that showed how 3 independent double boost interleaved converters work independently as power optimizers has been carried out. The operation of the converters has been analyzed using the voltage and current waveforms in different operating situations. Possible disadvantages due to the complexity of the structure can be diminished by the combined advantages of the proposed converter structure, such as high voltage gain, high efficiency, and interleaved operation. Thank you very much for your attention. And here we have some reference used in this paper. And if there are any questions, I will try to answer.
Thank you,
Thank you very much.
So can I have some questions, please?
I'll start with one. And
all right, sir. Thank you.
Thank you for that presentation. Interesting. How you have done the study using a simulator, I assume MATLAB Simulink, but how do you see the practicality if you want to when you want to implement this? What are the challenges compared to a simulated platform?
I think the challenges occur when we try to implement this perturb and observe algorithm. And this algorithm that I've used in this work is the simple. It's one basic. It's a simple one. And the difficulties, I believe, that occur when you try to increase the efficiency of the algorithm. And to measure the currents and the voltages, because you have to filter this electric when you using the algorithm.
Yeah. Thank you.
Thank you both. I hope there are no more questions, sir. Can we move to the next presentation?
Yeah.
All right, thank you. So it's interesting to know that we have one more presentation from Romania. Adrian Mihai Uras is going to present his paper titled AC-DC Microgrid Analysis using a hybrid real-time HIL approach. I request Adrian to take over the mic. Yeah, we can hear you.
Okay, I can share my screen.
Sure. Yeah.
Just a second, please. You can see my screen?
Not yet. I think it's about to start in a moment. Have you started the screen share?
Just a second. Yes, right now.
That's visible now. Please bring it to full screen mode.
Okay, just a second. Okay.
All right. I request you to limit your presentation to 10 minutes. Thank you.
I tried. Hello, my name is Adrian Mihai Ioraș. I'm from Technical University of Cluj-Napoca, from Romania, and my work name AC/DC microgrid analysis using a hybrid real-time Hill approach. The work presentation are in the loop simulation regarding to the power flow control in AC/DC microgrid. The microgrid topology employs to use the combination of the two bidirectional interlinking converter with a bipolar DC distribution voltage. The power flow control is achieved regardless of the load type and the mode of operation. Also, the independent control for each individual converter is possible. This feature being highlighted in the experimental stage. Just a second. Okay. The AC/DC microgrid topology is simulated in the real time through the Plex RTBox platform. And the active and the reactive power control stage are implemented using the DSpace MicroLabbox platform. So the structure of the proposed system contains two DC and AC type circuits delimited by the two bidirectional interlinking converter. The AC circuits you can see here in the right part contains the two contains the connection of the grid, the AC grid via the three-phase weighting transformer, and these circuits contain the LCL filter with the passive damping. The DC circuits contains the two voltage level provided to the differential connection of the output of each two AC/DC converter. So the DC circuits contains the capacitor filter and the DC loads and the renewable energy storage or source. So the converters, these two converters allow the power flow in both directions according to the requirements of the energy management system. Each converter can operate at the same time in independently rectifier or inverter mode. The power factor correction or compensation is achieved by the rectifier current injection into the both power converter regardless of the power flow direction. So the control stage, the control stage shown in this figure, this is identical for both converters. It is based on the DQ synchronous reference frame control by transforming the AC signals into the DC signals. The reference signal for this system is the DC voltage, voltage and the active power and the reactive power required by the AC grid measurement. And the measure signal for the feedback loop are the grid voltage and current of grid, the DC voltage measured, and the the DC current. This last part is measured or the output of each converter. So the rectifier or the inverter operation mode is selected by shifted with 100 and 1000 degrees by multiplying with the constant -1 by the measurement current grid and the modulation signal. This VM is multiplying with -1. To synchronize with the AC grid, I use the PLL blocks, phase locked up blocks. So the Hill simulation results you can see here. I studied in 8 cases. The first case is operation in rectifier mode with unit power factor. Here in left, they are the 3-phase current and voltage, and in right part, you can see the 1-phase or single-phase current and voltage. In all cases, the current is multiplied with constant 10 for a good resolution. Here you can see the reference value of the active power is set to 2000, and the value of rectifier or reactive power is set 0 for both converters. The DC reference is kept at the 3050. You can see with green color for each converter. Case 2, in this case, the rectifier mode with the first converter have a capacitive behavior. You can see here we have a phase shift between current and voltage on one phase. You can see here. The reactive power is imposed at the -500 voltage ampere reactive, and the second converter is working at the unit power factor. Case 3, in this case, the rectifier mode with the second converter have capacitive behavior. In this case, the second converter is imposed at the reactive power at the -500 VRA. The first converter is working at the unit power factor in this case. Case 4, the rectifier mode with the first converter having an induction behavior. The rectifier, the reactive power is imposed at the +500 and the secondary converter is working at the unit power factor. Case 5, the rectifier mode with the secondary converter having an inductive behavior. You can see here, I have a phase shift between the voltage and the current. Case 6, in this case, I have first converter is operating in the inverter mode with power factor unit. Here you can see the phase shift between the voltage and the current is 180. The second converter is working in rectifier mode. Case 7, in this case, I can see the reactive power is imposed at the -500 VRA, and the secondary converter is operating in rectifier mode with unit power factor.
Adrian, you have last 2 minutes to conclude.
Okay, this is the last case.
Thank you.
In the last case, the inverter operating for the first converter in inductive behavior. I can see here we have a phase shift between the voltage and the current. The second converter is operating in the rectifier mode with the unit power factor. In conclusion, this paper, the Hill simulation of the AC-DC topology with 2 DC voltage level has performed. At the AC-DC microgrid is simulated in real time through the Plex RT box platform. At the active and the reactive power stage are implemented using the DSpace microlab box platform. Analysis of the power management doing by the hybrid hill implementation. The results of the hill simulation are presented in the last section of this presentation, when it is observation the reactive power control regardless of the active power flow direction according to the power factor correction or compensation to be achieved according to the requirements of the point of common coupling or of the DC distribution grid. Thank you for your attention. If you have question, I'm listening right now.
Thank you so much, Andreas. Over to you, Dr. Raghir.
In fact, I don't have any questions. It's a very nice presentation and very nicely explained. Thank you. Thank you.
Okay, congratulations to you, Andreas, for that. So with that, we're moving to the last presentation of this session. I now call Fatima Masmoudi from Saudi Arabia. Her paper is on image recognition to detect COVID-19 violations. She's taken Saudi Arabia as a case study. Stage is all yours.
Thank you, Doctor. I am Fatima Masmoudi from Prince Sultan bin Abdulaziz University in Saudi Arabia.
Can we have your camera on? Can you please turn your camera on?
You mean the
turn
presentation?
Your video on. Come again?
You mean the presentation?
Yeah, of course, we would like to have your presentation. Will it be possible for you to turn your camera on for a while?
Yes, but just Mrs. Noof will present the paper. Just to.
All right, that's absolutely okay. You can start with your presentation. That's fine.
Okay, Noof, could you share? You begin. Good luck.
I couldn't get you, Fatma. Okay. Yes. Start with the presentation. Sure.
Okay. Hi, everyone. Good evening.
Can you please start with the screen share? Sorry, with the full screen mode?
Okay, sure. Okay. Hi, everyone. Good evening. Thank you all for giving us this excellent opportunity to be here today. I will introduce myself and my colleague. My name is Noof Baddah Al-Dosari, and my colleague is Amal Abdurrahman Al-Ghafez. Master students graduated in data science. I am one of the authors of the paper. The title is Image Recognition to Detect COVID-19 Violation, Saudi Arabia Use Case. Me and my colleague now are lecturer in Imam Muhammad bin Saud Islamic University in Riyadh, Saudi Arabia.
Could you please start the slideshow?
Okay. First we'll start with the presentation content. As you can see, KSA geographically, Vision 2030, COVID-19
I
KSA.
interrupt Fatima. Please start with your slideshow. We can only see the first slide of your presentation.
Okay, sure. Okay. KSA geographically, KSA is the fifth largest in Asia, the largest suffragan
Still
state in
unable
Western.
to see the next slide. I'm so sorry to interrupt you again and again. Kindly bring your presentation to the full screen mode.
Yeah, it's the full screen mode. You cannot see it now.
You're sharing the wrong screen, please. You're sharing the wrong screen.
Now
Can
it
you
is
check
on
again?
the fourth slide.
No, you're sharing the wrong screen. Can you do a share? Try to share it one more time.
you
Okay.
share the whole screen, not the PPT, the whole screen, because the diaporama is not visible for all.
Okay. Is it clear now? Is it clear?
No,
Yeah,
no.
we can
the,
see
the,
it
the
now. You
diaporama-
can manually switch to your slides. That's okay. I mean,
Okay.
yeah.
You can see?
Yeah, we can.
Okay. Good. As I said, KSA is the first largest in Asia, the largest sub-region state in Western Asia, the second largest in Arab world after Algeria. Okay. Vision 2030, there are three primary themes. The first is vibrant society, a thriving economy, and ambitious nation. The goal is to enhancing citizen lives by increasing protection. Can't move this. Okay, it's a protection for the country as a whole and for individual citizens.
We request you to change your slides as per the contents of your presentation. The slides are not getting changed. The slides are not getting changed as per your presentation. I think you are on the next slide, but we can only see the previous slide getting displayed.
No, please share your whole screen, not the PPT, the whole screen, the desktop.
There's no selection to share the whole screen.
That's absolutely okay. You just share the screen and change the slides as per the content.
Okay, you can see it now.
Yeah, we can see it now.
It's on slide 1.
All
3.
right.
Okay.
So I think you've already discussed this slide. You can move to the next one. Yeah, thank you.
Yeah, the goal. The goal is to enhancing citizen lives by increasing protection for the country as a whole and for individual citizens. The improvement of security for the country in general and the citizen in particular. Various security forces are distributed inside country and in the important virtual facilities of the kingdom. Okay, important point. Security passes according internal challenges and external. About the internal, it is unemployment, for example, and about the external, COVID-19. Okay, COVID-19 in KSA, as we all know, COVID-19 first appeared in China in 17 November 2019, according to the South China Morning Post. First case detected in KSA in the 2nd March 2020. Of course, Saudi Arabia issued some legalization like suspending Umrah, study suspension, hanging prayer in mosque, determine the penalty for infecting others. Okay. Also important point, any behavior that harms the security of individuals and does not respect the legalization issued by the Ministry of Internal is considered as a crime or legal violation. Okay, the problem statement, the growth of cities creates opportunity for violations, of course. Human resources only, it's expensive and insufficient. The government has reported an upsurge in violations of all sorts, including cyber warfare and the threats. Okay, the question here is how to help Saudian security organization to understand the situation of violation. Okay. Second slide. Okay, about the objective, the main objective is to help security organization in Saudi Saudi Arabia to understand the violation situation and to improve as well the security in the country. Okay. Also, the first point is to define legal violation related to COVID-19 and study the impact of COVID-19. Of course, using artificial intelligence. Okay, about the state of art in image processing summary, we have collected some papers made by other authors. Our objective is to predict whether violation related to COVID-19 occurred, such as not wearing a mask, shaking hand, and others. Okay, here about the methodology. First, we will talk about data collection. After that, we'll talk about data preparation, which contain 3 parts: data labeling, feature extraction, data pre-processing. Then we will move to image classification that contain machine learning models for image classification, also deep learning models for image classification. After that, we will have the result if it is either violation or non-violation. Okay, about the data collection. Extract data from social media platforms like Instagram, Snapchat, YouTube, and Twitter. Okay, the data was extracted from 2019 till 2021. Okay, the collected number of data set is 2,313 images. Okay, now we will move to data preparation. As you can see, in data labeling, the first line is non-violation images. They are wearing mask, not shaking hand. Okay, the second line of images, it's considered as a violation. They are shaking hand, hugs, not wearing a mask. Okay, the second point is feature extraction, or the second part. Feature extraction, we use OpenCV, a public or a publicly available library with computer vision algorithm. Also, we filter out the images that are neither JPEG nor PNG. Okay, about data pre-processing, image resizing, text removal from the images, data augmentation. Okay. Now we will move to image classification that contain machine learning and deep learning. About deep learning for image classification, classification using ResNet 152 model and representation and optimization. About machine learning for image classification, we use 6 classifiers such as SVM, decision tree, KNN, SGD, stochastic gradient descent, Navy Bayes, random forest. Okay. Now we will move to the part of results. As you can see in the table, deep learning results. Deep learning gets accuracy 97% and AUC 96%, which is very good percent. About machine learning results, the highest was random forest 82 in accuracy, 82%. About the AUC, the highest was also random forest, 85%. Okay, deep learning versus machine learning. The ResNet or the deep learning model, ResNet 152 was better than machine learning. It is 97%. And the random forest was 82%. Okay, about the challenges, collecting dataset from social media platforms was very challenging phase. Also, the labeling, the manual labeling for the dataset was also challenging. Cleaning the data by cropping boundaries. As you know, some images has boundaries, text, emojis, numbers, stickers. Which is they are occlusions to the image. Okay, as a conclusion and perspective, deep learning ResNet 152 model achieved 97% accuracy in detecting crimes in images. To extend this work, in the future work, of course, we will expand the dataset amount and variability. Also, we will implement or try to implement other types of classifiers such as RNNs, recurrent neural networks. Okay, thank you all for your time and attention. It's a great pleasure to be here today. If there's any question, I'm ready to answer.
Thank you so much, Nov. I request Professor Ragil to come up with his queries.
Thank you for the. I just have a couple of quick questions. One, how large is your data set? How large is your
The
data?
set is 2,313 images.
Right. And you were talking about multiple behaviors like hugging, handshake, and all that. So have you identified them in groups and then done the deep learning or ResNet? How did you do the experiments? It was not clear.
It's a binary classification. If the image or the person in the image wearing mask and not shaking hand, not hugging, not kissing, it says non-violation. Okay, if there is a handshaking, not wearing mask, hug, it is labeled as violation.
Just 2 classes. Okay, thank you.
Thank you so much. I now request the session chair to present his special remarks regarding the papers and the track.
Thank you, Naya. Thank you, everyone. Thank you all for your presentation. Congratulations on the publishing the paper. And we started from blockchain, went into a lot of different areas, power related, DC conversion, and then DC AC, microgrid related, and now finishing with COVID. I hope we had a mix of different papers and different areas, and had a good set of presentations. So once again, I would like to congratulate everyone for getting your papers accepted, all your work and hard work, and coming and presenting them here. And thank you for your sharing all this interesting work with us. And I'll conclude. Thank you, Neha.
Thank you, sir. I sincerely thank our authors for their excellent presentations in this session and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT 2022. I extend my special thanks to session chair, Professor Roshan G. Ragil, for chairing the session and sharing his precious comments. As a token of appreciation to the chair on behalf of Team ICICT 2022 and Global Knowledge Research Foundation, I'm delighted to share this on-screen certificate of appreciation with you all. Thank you for your valuable presence, sir. I kindly request you all to turn your cameras on for a while so that we can capture this wonderful moment together and make it more precious, I would say, with our lovely smiles. So can I have you all on the screen, please? I request Hamidi and Amal to turn their cameras on for a few seconds so that we can capture the moment together. Thank you.
Thank you so much, everyone.
Thank you so much, everyone. Stay safe and take care.
Thank you.
Thanks once again.